Hello, my name is Shruti Vinod, and this is Lab Report 3 for Physics 2212. So the purpose of this lab is to observe how resistors, capacitors, current, and other aspects of circuits interact with each other and to measure the current and potential differences in the circuit. So we use loop rule, node rule, Ohm's law, energy conservation, and then we analyze capacitors, resistors in series and in parallel. And basically, what we found out is higher resistance leads to a longer capacitor discharging time, and currents change over time when there's a capacitor and resistor involved. So, diving into the main physics ideas here, the loop rule explains that the round-trip potential difference of a circuit in a steady state is equal to zero, while the node rule states that the current entering a circuit node is equal to the current leaving the node. Potential difference in a resistor is equal to current times resistance, while the potential difference in a capacitor is equal to charge over capacitance. And I, which is current, is equal to change in charge over the change in time. And for an RC circuit with one capacitor and one resistor, we have potential difference here. So basically, for series and circuits, and in general for this lab, our system is ammeter and voltmeter, and our surroundings are the circuit components. So my prediction for the current was that using the node rule, all the ammeters should read the same current. And using the loop rule, we have derived that the current should be 0.02 ampere. And so the setup for our circuit, which is in series, is two 1.5 volt batteries, two ammeters, 47 ohm resistor, and 100 ohm resistor. And basically what happened was the model matched your prediction of the current, which is 0.02 amperes. And when it was reversed, it was negative 0.20 amperes. So one ammeter was replaced with a voltmeter. The other ammeters reading dropped to 0 amperes, while the voltmeter read 3 volts. So basically, this is because on one side, electrons are building up, but since there's no wire, they're unable to flow on the other side, and this results in a potential difference of 3 volts. And with no electrons flowing, the current is 0 amperes. So here we talk about the potential difference in each stage, so from A to B, 3, B to C, 0, and so on and so forth. And if you total them all up, it supports the loop rule, which is basically that all of them summed up equals to 0. Now for the ammeter and parallel circuit, we basically remade the circuit to have an ammeter parallel to the resistor. And here we calculated the current through both ammeters is 0.06 amperes because the current now chooses to flow through the new ammeter instead of through the 100 ohm resistor. So basically because of less resistance and greater current, and the current chooses a path of least resistance. And as you can see in the picture below, I have derived what the resistance for each part is. So now we get to the third part, which is our RC circuit experiment. And this circuit consists of a 10 ohm bulb, a 20 ohm bulb, a 9 volt battery, and a zero point 0.2 capacitor. When all of these are first connected, the light is very bright and then gradually fades until it's fully out. And this is like the current starts high and then approaches zero as the capacitor charge. And when the battery is removed and the capacitor is discharging, the same thing happens, but as we can see in the next part, it just takes more time. So these are the measured times for the 10 ohm and the 20 ohm batteries. And as we can see, the discharging time takes more than the charging time. And I've stated the sources of errors, which is like rounding errors, connection issues, and then we assume that there's no resistance in wires or ammeters, and there's also like timing errors. Okay, so what if you charge the capacitor with no resistor in the circuits? How quickly would our ideal model predict the capacitor to reach full charge? And using an ammeter, we have to measure how long it takes to charge the capacitor when connected directly to the battery, and then discuss why the measured time is different. So if we charge the capacitor with no resistor in the circuit, then our ideal model would predict that the capacitor would reach full charge practically instantaneously. This would not happen in real life due to some resistance in the wires. And by using an ammeter to measure how long it takes to charge the capacitor, when connected directly to the battery, we see that since the real life emitter has resistance, we would have a lower RC experimental value and smaller voltage values, and therefore our measured time would be longer than the predicted time. So in conclusion, we were able to predict and find the current of a circuit, demonstrate the node rule, loop rule, and find the charging discharging types of two different types of bulbs in an RC circuit, and observe how a circuit acts differently with both the resistor and capacitor. And thank you so much.